So, hello everyone, welcome back to my YouTube channel. I am Nandini and I scored 632 out of 720 in NEET 2024 examination and so could not get a government MBBS seat. So, I'm preparing and hustling for NEET 2025 examination. In this video, I'll be sharing with you all the further questions of Physics Allen Achievers Test Series. For the question number 1 to 15, you can visit my channel. I have uploaded there along with the solution. In this video, I'll be covering questions from 16 to 35. That is end of section A. So without wastage of any further time, just let's jump into the video. And if any modification or correction needed, then please do feel free to comment. I'll really be glad to listen to your comments. So without any further wastage of time, let's get into the video. I'll keep the video as brief as possible and as short as possible, and I'll try to explain you all the questions so that you need not hustle for searching the answers, because as an aspirant I myself know that how important solutions are to us. So let's get into the video. Here in question number 16, equivalent resistance across AB has been asked. So like you need to solve this circuit. I have kept this paper with me, so I'll be solving here. This is much cleaner, so you'll get a better understanding. Yeah, equivalent resistance is being asked. I also share yes, wait, I'll give you. Sorry for the inconvenience. See here, this will be the simpler circuit. Here it's A, so here also it will be A. Okay, so here the resistance has been kept here, so it cannot be A, we'll label it as Y. Here also it will be Y. Here it's B, so here it will also be B, here also B. Okay, and then here also it will be, and here also it will be B. The simple circuit will look like this, and the R equivalent will come out to be 12 upon 4, that is 3. Okay, so yeah, this done. Now the second one. So in the circuit, the point B is earth. Earth means the potential becomes 0 of point B, and potential at A has been asked. So first of all, we'll calculate the total current moving through the circuit. So like this is 50-volt battery. It will supply a current, and the current will not go this way because it's 0 potential. So it will turn here and it will circulate like this, in this fashion. So we know that V is equals to I into R. V is 50 volt. I we don't know, and resistance all are in series. So the equivalent will come as 25, which means that I will be 2 ampere. Okay, and now if we'll equate here, so it will be VA minus VB, which is the potential difference, is equals to I, that is 2, into resistance is 7, 5, 12. So it comes out to be 24 volt. 24 volt. So here it's 24 volt. Okay, now moving to the next question, which is question number 18. So here you need to apply the KVL, although it's not a loop, but you will have to go through that only. So we'll start from A. So it will be VA. Now you need to apply this trick which I did. First of all, in the resistance portion, you will have to like mark like this. This is the positive terminal, so positive, negative. Again, this is the negative, so negative, positive, and again this is a resistor, so we'll conventionally mark it as positive, negative. And now whichever comes at the end, whichever sign, that we will put up in our equation. So just follow me. VA, so the last sign is minus, so it will be minus 6, that is 3 into 2, 6. Then minus 5 volt, then plus 3 volt, and then this is minus 3 times 6, minus 6 is equals to VB. And here VA minus VB has been asked. So VA minus VB will be 6, 6, 12, 5, 17, and plus 3 minus 14, so it will be plus 14 because VB comes this side and this goes this side, so VA minus VB will be plus 14 volts, so answer will be plus 14. I hope that I am making it clear and the view is proper for you all to understand. Okay, now coming to the next question. Okay, the resistance of a galvanometer is 90 ohm. So in this question I'll give you a trick how to solve. The resistance of a galvanometer is 90 ohm if only 10% of the main current may flow through the galvanometer, in which way the value resistance is to be used. It is very easy because what we need to say is that 10% current has only to pass through this one, which means that 90% of the current needs to pass from certain other resistor, which will be connected in parallel obviously. So this will be the galvanometer and this resistance will be in the parallel. Now what should be the resistance of this resistor so that 90% of the current flows from this? So we know that current is inversely proportional to resistance, so the resistance needs to be low so that most of the current flows from this side, because current will flow from that side which has less resistance. So 810 ohm and 810 ohm gets cancelled, 10 ohm and 10 ohm remains, and we are connecting it in parallel so that most of the current flows through this. So it will be 10 ohm in parallel and you'll get this correct. So this is a trick which you can just apply. Okay, moving on to the further question, which is the 20th question, and like it is just a theoretical question which you need to remember. So internal resistance of a primary cell depends on all of the above. You can keep it in mind. Nature of the electrolyte very much justified. Area of the plate symbols and the concentration of electrolyte and distance between the plates. Moving on to the next question. Reading of the ammeter is being asked. Okay, so for this a simpler circuit is to be drawn, so I'll show you that one. Here you can see it. Simpler circuit is has been drawn. Redraw the circuit, and then you need to calculate the equivalent EMF of the two cells in the branches, which is E1 R2 plus E2 R1 divided by R1 plus R2. So that comes as 2 volt and R is equals to 1 ohm. So the current will come as 2 upon 3 ampere. Okay, so I hope that it's clear. 2 upon 3 ampere. Now this question is regarding power consumption. So we know that the voltage is constant over here, so we know that power is equals to V square upon R. So voltage is constant, which means the power is inversely proportional to resistance, right? Just a minute. Okay, power is inversely proportional to resistance. So here the resistance comes out to be 1 ohm. Okay, and here it comes out to be half ohm, and here it comes to be 1.5 ohm. So the one which has the least resistance will have the highest power consumption, which is R2, which is half ohm. So it will have the highest power consumption, which is P2, and then which one has the largest resistance will have the least power consumption, which is P3. So the answer will be third option. Okay, so this is a Wheatstone bridge, and this is like Wheatstone bridge in series with 1 ohm, and this again will, when you calculate, it will come out as 1 ohm. Okay, now next, again this is a power wala question. So again power is equals to V square upon R. When you equate this, V is like getting doubled over here. In USA, like V is halved. Okay, so accordingly power will also get reduced by a factor of 4. Okay, and for 60 watt bulb used in India we are, then the resistance of 60 watt in USA will be. Okay, so when you equate everything, so you'll get R upon 4. Okay, now moving on to the next one. In a Wheatstone bridge, P, Q, R and S is how much put in parallel. Okay, so you can take it like this and this. Okay, P, Q, R, S, and with S you need to put another resistance in parallel, and then you will get the ratio like P upon Q is equals to R upon P upon this one, which means the same only. P upon this, let's suppose that this resistance in parallel is X, so the equivalent resistance become Sx divided by S plus X, okay, is equals to Q upon R. When you equate, you'll get this one. Okay, hope it's clear. Now this again Wheatstone bridge, so we know that 100 upon L1 is equals to X upon L2, and here when you will read the question, so you need to solve it and it will come as 100 ohm. If you want the solution, I'll give it over here only in a brief manner so that it becomes easier for you all. So here it is saying that when more resistance of 100 ohm is connected in parallel with a known resistance X, here 100 ohm is being connected with the X resistance in parallel, ratio of L1 upon L2 becomes 2. Okay, so we'll take it as 100 upon L1 is equals to, this equivalent resistance becomes 100x divided by 100 plus x divided by L2, right? 1 upon L2. And here it's saying L1 upon L2, so we'll rearrange it. 100 plus x times 100 divided by 100x is equals to 2. Okay, so 100 and 100 gets cancelled. 100 plus x divided by x is equals to 2. So 100 plus x is equals to 2x. So x is equals to 100. So 100 will be the answer. I hope it's clear. Okay. Now this one, again equivalent resistance. So we can see here that it is a balanced Wheatstone bridge. R, so this will get cancelled. So this becomes 2R, this becomes 2R, and this also becomes 2R. 2R in parallel becomes 2R upon 3. Plus the R, which becomes 5R upon 3. So this will be the answer. Moving on to the next question. Okay. So this is a statement-wise question, assertion, reason. You need to first read the question properly. It's not sigma E equals to J, it's J is equals to sigma E. So reason is incorrect, assertion is correct. So the answer will be second option. Okay. Now 28th one, energy stored in the capacitor during a pulse of duration 4 millisecond, the power delivered is asked. Has been asked. So power is equals to energy upon time. You all know, and energy is equals to half CV square and divided by time, which is in milliseconds. So we'll keep it in seconds, 10 to the power minus 3, and then the power will come back as 10 kilowatt. So answer has to be given in kilowatt. Again, question number 29th, distance between the place double to the origin value then. So if you get any two correct, then you should go with all of the above. We know that capacitance is equals to epsilon naught A upon D, and increase the distance, then capacitance will reduce. So the capacitance of the capacitor is halved. Charge remains the same because charge is conserved, and because Q is equals to CV, charge remains same and capacitor is decreased, which means that the capacitance is decreased, which means the potential will increase. So all of the above will be the answer. Now again, in this question, if we'll connect two spheres, then V1 equals V2 and V is equals to KQ1 by R1 is equals to KQ2 by R2. KK gets cancelled, which means a decrease in the energy of the system unless Q1 R2 is equals to Q2 R1, because here then the energy will not be decreased. Okay, moving on to the next question. Again, this is a capacitance question. Equivalent capacitance has been asked, so we can see that these two are in parallel. So the equivalent resistance becomes 4 ohm, because in capacitor the things are opposite of resistor. So 2 and 2 becomes 4 ohm, and then this 4 ohm and this 4 ohm will be in series, so it again becomes 2 ohm, and this 4 ohm, this and this will be in series, so this becomes 2 ohm, and 2 and 2 in parallel becomes 4 ohm. I am so sorry, 4 microfarad. I am really very sorry. So it will be 4 microfarad. I hope you got the question, the solution which I wanted to tell you. I just mispronounced ohm, but it should be farad. Okay. Now moving on to the next question, number 32. Capacity of the capacitor as shown, the equivalent capacitance between A and B, and the charge on the 6 microfarad. Okay, equivalent capacitance between the points A and B. Okay, so this is A, this is A, this is A, this is B, this is B. Now let's suppose this is C, so this is also C. When you will make the equivalent capacitance circuit, then you will find that the equivalent capacitance comes out to be 6 microfarad. Okay, you can make it like this: A, then C, then B. So A and C has 6 microfarad, and B and C has 9 microfarad, and C is continued over here. So yes, so this will be the short circuited, right? So this will be short circuited, and A and C also has A and C 6, A and C has 12 as well. So this will be in parallel, 12. A and C, and then B and C. So this 6 and 12 becomes 18, and this 18 and 9 in parallel. So 18 into 9 divided by 18 plus 9, which is 27. 9, 3, 27. 3, 6, 18. So it becomes 6 microfarad. I hope that you understood it. Now, Moving on to the next question. Okay, this is a debatable question a bit, because I think that none of the options are matching, but let's see what happens. The answer is given as option number 2, but if you ask about with that's why I did not attempt this question, because I thought that work done is equals to the energy stored is the work done itself. So energy stored will be half CV square, which is C equivalent, and C equivalent here will be 3C by 2. So it will be half into 3C upon 2 into V square. So this will be 3C by 4V square. Again, I'm not sure with this answer because I doubt this answer. So let's see what happens. Till then, let's keep it on hold only. Okay. Next question. Next question is that of ratio of potential difference between 1 and 5 ohm 5 microfarad capacitor. So the 5 microfarad capacitor is connected with this 10 volt battery, and this is in parallel with this, and this one is parallel with 3. So first of all, we will take the potential of the 5 microfarad, that will be 10 volt. Okay, and then about this 1 microfarad, right, we need to find the potential so that we can take the ratio. So we are done with that 5 microfarad capacitor, that will be 10 volt only. Now these all are in series, so the we can say that Q is equals to CV, right? V along the whole, like 3 and 1 are in parallel, so it becomes 4. Okay, so we will combiningly tell it as 4 microfarad, and we will calculate the charge. Q is equals to C. So equivalent capacitance will become what? 2 and 2 in parallel, it is 1, and in 2 and 2 in series will be 1 in case of capacitor, and it is in series with 4, so it will become 4 divided by 5. Fine. So capacitance will be 4 upon 5 into voltage will be 10. Okay, here it's 10 volts, so this will become 8 microcoulomb. Okay, now 8 microcoulomb will flow through all these. So from like this 4 also, it will be 8 only. So we know that Q is equals to CV. So Q is 8, C is 3 and 1 4, and V is V. So this becomes 2 volt. That is the voltage across this 1 microfarad, because these both are in parallel. Okay, now we will take the ratio. So 1 microfarad has 2 volt and 5 has 10, so this will be 2 upon 1 2 upon 10, which is 1 upon 5. Okay, I hope that it's clear and it was clearly visible. You can see. Moving on to the last question, today's last question of this video, that is, in order to obtain a time constant of 10 second RC circuit, resistance itna, what should be the condenser capacity? The time constant is equals to RC. We know that R is 10 to the power 3 into C is equals to 10 seconds. Again, the C has been asked in microfarad, so when you convert it, it will be 10 to the power 4 microfarad. So I hope that you all enjoyed the video, and if you did so, then do like my video. It really motivates me to make further videos, and if you want further solutions as well, like that of chemistry and biology, then just feel free to comment, and do let me know how you find the video, and let's meet again in next video. Till then, keep hustling hard and keep practicing.